In the next two videos, we'll be putting our drawing techniques into practice, demonstrating how to create 8 basic primitive shapes in processing. In the first video, we'll cover points, lines, ellipses, and arcs. And in the second video, we'll cover rectangles, quadrangles, triangles, and polygons. After completing these two videos, you'll be prepared to complete your first assignment for this course, an activity which demonstrates your ability to draw and be creative with processing. Let's get started drawing in processing.
Here we are in processing, and I've just opened a new empty sketch. Before you begin working with any project in processing, you want to set up the fundamentals of your sketch in the text area. In this case, that includes comments, canvas size, and the background color. So the first thing I'm going to do is write a new comment. And this comment is just going to be describing this project. So I'm just going to say drawing points, lines, ellipses, and arcs. So a comment is an explanatory note embedded within the code. Comments are used to remind yourself and to inform others about the details of the code. Single line comments, as you can see, are signified with 2 / characters. Comments are ignored by the compilers, so it doesn't matter what you say, but it's good practice to use comments and to make sure that they're meaningful. I'm also going to add a few more comments for the different areas of my code. You'll notice that if I don't include the 2 slashes, it's rendered in black instead of gray. Processing uses coloring of the text in order to help you better to read it and to navigate large blocks of code. So I'm going to add those comments back in. So, as I mentioned in the last video, one of the first functions that you'll need to call upon in a new processing sketch is the size function. The size function dictates the size of the canvas, or the output window of processing. So, as a reminder, to call upon the size function on a new line of code, type size, beginning with a lowercase letter. Processing is case sensitive. Then an open parentheses to prepare for the argument. And if you recall, the argument takes 2 numbers. The first number is going to represent the width, and the next number is going to represent the height. So I close that with a parentheses, and I'm going to end this line of code with a semicolon. It's always important to end your functions with semicolons, or else they won't compile properly. Let me show you what I mean. If I leave the semicolon off and I press the run button, I'm going to get an error. See, it jumped down to the end of my code. So this is a little bit confusing, and it simply says unexpected token null. Now this might be a big headache for you if you have a lot of code and the error compiler is pointing you to the bottom of your code. So always remember to include your semicolons at the ends of functions. Once I put that semicolon back in and press run, it should run just fine. There we go. So the output of this code that we see here is simply one thing: a window that is 600 wide and 400 pixels high. Typically, the next thing that you set up with your setup code is the background color for your window. Defining your background color simply involves typing the background function. That is background, open parentheses for your argument, and then you're going to place the color inside the parentheses. I'm going to close this off just for safekeeping while I grab the color. So how do I know exactly what to expect for the colors of the background? Well, let me show you a handy tool that's included with processing that can be found in the Tools menu. This is called the Color Selector. When you launch the Color Selector, you're going to be given a red, green, blue color selector. This allows you to scroll through the various colors here and then choose the hue and saturation levels here. The output of that will appear over here, and the important number that we're looking for is this 6-digit hex number with the pound sign in the beginning. Once you've chosen a color that you like, I'm going to choose a light yellow, you're going to copy this hex along with the pound sign, and then I'm on a Mac, so I'm going to press Command C to copy, and then I'll go back inside my background and paste this color inside the argument area using Command V on a Mac. And those would be Control C and Control V if you're on a PC. So I have the canvas set at 600 by 400, the background set to light yellow. Let's press stop and then run again to see how that looks. Ah, that looks great. Now, if you're new to processing 2.0, you might be used to typing the smooth function. What exactly is the smooth function? Well, that's a good question. And before I answer it directly, I'd like to point you to the reference. At any point when working and processing, if you encounter a function that you're unsure about, you should look it up in the reference. To do that, highlight the code, right-click on the function, and select Find in Reference. This is going to launch the processing reference for that function. The reference is an excellent tool. Always keep your references handy when you're programming and processing. In processing, the reference includes the name of the function, examples, a description, syntax additions, different parameters that it takes, and what it returns, including related functions. Now, this demonstration here of these two circles is the best way to show anti-aliasing. That's what the smooth function does. Anti-aliasing allows for objects to appear smoother at various sizes. As you can see on the right, this is no anti-aliasing. That's no good for us. If for some reason you wanted to turn anti-aliasing off, you would instead type no smooth. Now, I must change the S on smooth to uppercase because processing uses what's called camel case. This means that when a function combines two different words like the words no and smooth, the first letter will be lowercase, and then subsequent letters in subsequent words will be uppercase. That's called camel case, and you'll encounter it often in processing. Now, I actually want to keep smoothing on, and because I'm on processing 2.0, I'm simply going to remove this line of code, and I know that the smoothing will be there. Okay, so we've set up the canvas size and the background color for our sketch. Let's draw our first object, the point. To use the point function, type point, and then open for the argument for the point. If you recall, the point takes two arguments, and that is the x and y value locations where the point should be drawn. In this case, our canvas is 600 pixels by 400 pixels, and I want to put the point in the upper left-hand corner. So I'm going to type 100, 100, close the parentheses, end with a semicolon. You'll notice too that I've separated arguments by a comma. Okay, so let's take a look how this looks. I'll press stop and then run. Uh-oh, where's my point? Well, actually, you may not be able to see it on your screen, but it's there. It's actually right above my mouse cursor here. And the problem is that by default, points are drawn at 1 pixel wide and 1 pixel high. That's the smallest element that something can appear on the canvas. Now, this may not seem useful, but it will when I introduce to you two modifications of the point function, and those are stroke and stroke weight. Stroke allows you to change the color of the outline of any shape or object, and stroke weight allows you to change the weight of the stroke. Let's see what I mean by that. So, first is the stroke. I'm going to change the color of this to a bright red so that we can see it. So I'm going to type stroke, open my argument, and I'm going to grab that bright red color from the color selector over here. Here we go, something really bright. Copy this and paste it over here. Close my parentheses, add the semicolon. Let's press stop and run and see if we can see it any better. Well, I can still see it, but just barely. Well, this is where the stroke weight function comes in. So I'm going to type stroke, lowercase, and then with an uppercase W for the camel case, I'll type weight. And then I'll open the arguments. The stroke weight takes an argument which defines the amount of pixels wide that the stroke outline should appear. I'm going to put the number 5 here and see what the results are. So I'll press stop and then run. Ah, there we go. There is our point right there. Now, I can make this very dramatic by changing this to a number like 50. Ah, there we go. Now, this doesn't really work because in this case it appears more like an ellipse. In this case I could have just drawn this as an ellipse, but you'll see later why the ellipse is slightly different and a bit more flexible than a point. I'm going to put this back to 5 for now. There we go. I like that there. Now we'll take a short break to see how things are going with a brief quiz. Now, in processing, the order that your code appears matters. You'll notice here that I defined the size of the window and then the background color. But with my point, I set up the parameters for stroke before the point appeared. Let's see what happens if I move these two lines of code after the point. Our point is down to 1 pixel and it's black. So we've lost the stroke and we've lost the stroke weight. This is no good for us. Why is that? Well, let me undo a few steps and I'll talk about it. When you press run, the compiler reads your code line by line, and it's setting up any instructions that your code has. In this case, when it gets to the point area of our code, it's informing in the future, anytime you use an object with a stroke, use it with this color, and anytime you change the stroke weight, put it at this level. So if we tell it to draw a point before we give it the instructions of how the stroke and the stroke weight should appear, it's going to get confused and the results will not be what you expect. Okay, so I've restored this. I'll press stop and run and make sure it's back. Great. Now, let's draw a line. So right under our line comment code, I'm going to type line and open my argument. Now you remember that the line function takes 4 arguments. That's the xy value of the starting point and the xy value of the stopping point. I'm going to draw my line as a diagonal starting from the lower left and moving to the upper right. So the first point will be 100 over from the left and 300 down from the top. The next point will be 500 over from the left and 100 down from the top. So this should cascade from the lower left to the upper right. Close the argument, add the semicolon, press stop, and run. There we go. Now, take a look at what else you notice. The line carries and has inherited the parameters of both stroke and stroke weight. So, if we want to change those parameters, we'll have to redeclare them. That's easy enough to do. I'm simply going to copy these 2 parameters and paste them so that they reappear right before my line. I'm going to change the color of my line. I'm going to have it be sort of a neutral green. Copy that hex code, paste it into my stroke area, and I'll lighten up a bit on the stroke weight. I'll set it down to 3. Leave these parameters the same, press stop and run. Let's take a look. There we go. So far we have 2 objects in 2 different colors. So let's draw our ellipses here. So you remember that the ellipses takes 4 different arguments as well, and those are going to be the x and y value of the center of the ellipses, and then the next 2 values are going to be the width and the height. So for my ellipses, I'm going to place it in the lower right hand corner. Open my parentheses for the argument, and I want this to be 500 over. I want it to be 300 down. And I want this to be a perfect circle, 100 wide by 100 high. Close the argument, add your semicolon, and let's see what we have here. Okay, so there's our ellipse, but what is this white area here? We didn't really tell it to do that. Well, let's see what the reference has to say about this. Right-click on this function and select Find in Reference. When you go here, you'll see that the ellipse has an external stroke and an internal fill. So what that means is that in order to change the interior color, we're going to need to call upon the fill function. Let's close the reference and go back here. So, fill. If I type fill, open my parentheses, what it's going to expect is a color. And what I want to do is match that same green that I used for the stroke of the line. So I'm going to copy that parameter here, paste it down here, close my parentheses, add my semicolon, press stop, and run. There we go. So this is looking good so far. The last thing I want to do is to draw an arc. So as you know, an arc works almost identically to an ellipse, but it only uses a portion along the exterior of the circle. So those are signified by two extra arguments at the end of an ellipse, the start and the stop, measured in radians. So I'm simply going to copy the ellipse code and paste it onto the arc. I'm going to grab this and change it to arc, and I'm going to move it so that it's slightly to the left of the green circle that's currently on the screen. So I'm going to make sure that it starts at 400 over, and then I need the start and stop arguments. Now these are measured in radians, and a circle contains 2 pi radians. So if I start at 3.14 and end at 6.28, this will roughly draw a half circle with a fill. Let's take a look at that. There we go. So here is our arc, and it contains a fill. If we wanted to remove the fill from this, simply type no fill. Open, close, close. So this is the first time we've had a function with an argument that contains nothing. We simply told it no fill. We don't need to say anything about the argument, but we still need to open and close the parentheses and include the semicolon. Let's see how it looks now. Excellent. Okay, so I've gone over comments. I've reminded you how to set up your sketch. We've taken a look how to define the background color and how to use the color selector in the menu to select your colors. And we've gone over how to draw points, lines, ellipses, and arcs. And we've also discussed how to use the stroke to change the color of the outlines of objects, how to use the stroke weight to change the thickness of that outline, and how to use the fill to change the interior color of objects that contain a fill. In the next video, we're going to go over the remaining 4 shapes.